Hey everybody, welcome to Mammoth Interactive's YouTube channel. First of all, I want to thank you for watching this video. And remember that this channel doesn't do Patreon. Instead, we sell our digital courses down below. And every single dollar that we get from the products you buy below goes into making more content. The best way to help out this channel and Mammoth Interactive is to subscribe to Mammoth Interactive's huge library of content. Get thousands of hours and hundreds of courses for a low price down below. We have a monthly option and a yearly option. Thanks for listening, and I'll see you in the video.
Welcome back, everyone. In today's tutorial, we'll talk about primitive types. In order to talk about primitive types, we'll be using RexTester to provide some examples. So before we get into the types, let's talk about variables and constants, as we will need these. So variables, variables are something you declare once throughout the program, and they can be changed throughout the program. So variables are declared once and can be changed later on. And then we have constants. And constants are declared once and can not be changed later on. So this is declaring a constant. We'll begin with the keyword const, and then let's say an integer, and then let's just declare a simple integer up here. But first, let me explain the naming conventions. Naming of variables or constants. So this is how you want to be naming your declared variables. So pretty much they have to start with a letter, and then they can be followed by either a number or an underbar. So let me declare a simple integer. So my int is equal to 1. You can also declare it by saying my int is equal to 2. And then you can also do my int 1 is equal to 3. So these are all possible ways of declaring something. Pretty much. So let's also do that with our constants. However, I like declaring my constants in all caps because they stand out and you can tell which item is a constant or not. So let's say a const int, and then this is equal to 100. So these are all possible declarations of your integers, or whatever you're declaring. So those are the basics of how you can declare items. They have to start with a letter and then followed by either an underbar or a number. These are possible. They don't have to, but they can be. So can be. So now let's talk about our primitive types. These range from. So let me write them down. I'll be doing int, float, character. Let me throw in double right after float, and then the most simplest of them all is Boolean. So let's go through an integer. So ints by default are 32 bits and can hold numbers from, it's a big number, so bear with me, negative 2000, excuse me, that's not 2000, I think it's in the billions, 483 and then 648, to positive, okay, this number, I don't know the exact way of pronouncing it, so I'm not going to try. And then 647. So that is the range of what an integer can hold. it is by default signed, which means it can have a negative numbers, as you may see. So, let's do a constant and a non-constant of it for all of these. So let's do int and int is equal to 1, and then const int the constant in, let's say, is equal to 2. So that's pretty much an int. That's pretty much what it will be. So let's move on to a float. So floats are by default 32 bits as well, and they can hold approximately negative 3.4 times, let's see, I think it's 10 to the 38. 8, and then to positive 3.4 times 10 to the 38. So a pretty big number. So how we declare these is same thing, float. A float is equal to 2.56, and then f, because they have to be followed by f. So let me write it down. Or ends with f. Otherwise, it will assume it's a double, which a double is just a much larger version of a float. And a float also is accurate to 7 decimal units. So 1, 2, 3, 4, 5, 6, 7. So that's about as accurate as we'll get. Then constant float. Float. My float equal to 2.1415, so on. So that's a float. Let's go with a double. They are 32 bits, so these are, 64 bits, hence them being larger than a float. Let me write it here, decimal. So there are 64-bit decimals. These hold a very, very, very large number that I will not write. And they are accurate to 15 to 16 decimal units. So double, let's say a double, 2 point, something. These do have the option to end with an F. They don't necessarily have to, but it's a choice. But I wouldn't. It's not necessary. It's just it's possible. Then my double. And then there you go. So that's a double. So characters, they hold one value at a time, and they can be anything from a letter to a symbol. And so let me go ahead and write that down. So character, my car is equal to A. And then you can do constant character, my const care, which is equal to B. Actually, let me do this just to show that constant. If constant field requires a value to be provided. I think this might be it. Constant. I declared a constant somewhere that I need to take back pretty much. That's the error that I'm getting. A constant field requires a value to be provided. Oh, excuse me, right here. That should fix it. And I believe this can be const as well. So let me put that back up there. So that's a character. Again, one item at a time. If you try to do two, we'll get an error. So now let's go to Booleans. So bool holds the value of true or false. And these are declared the same way. So Boolean, my bool is equal to true. And you can have a constant one. Let's do constant Boolean, my const bool, which is equal to false. And there you have it. So these are our most basic types. The simplest ones that I can come off my head. There are slightly different versions of an int. So I'll write these down right below by doing this. So we have, let's go with a 8-bit version of an int. The 8-bit version of the int is called a byte. So these are by default signed. Unsigned. So byte, my byte is equal to let's do 120. The range here is from 0 to 255. And then we can do a constant of these as well. So constant byte, my const byte is equal to 255. So now we have I forgot to write the 8 right there. So 16-bit version of an int is called a short. And this goes from negative, so range is negative 32. And let me see the actual number behind it. 32. I'll come with it in a bit. 678, or excuse me, 768 to 32, 767. So this is the actual range. It is by default, of course, signed. As you know, we have the negative up here, so it's got to be signed. So short, my short is equal to 3200. Then const short, my const short, and then make this negative 32. And don't forget the equal sign here. And then our last one is a 64-bit version of an int, and this is called a long. The range on the long is quite big, so I'll shorten it by going with negative 9.2 times 10 to the 18 to 9.2 times 10 to the 18 as well. So that is the range. So it's long, my long, and then quite a big number, I believe. I think that might be big enough. Yep. So then const long. My const long. And I think that should be within range. And so there you go. So these are different versions of our integer, pretty much. And then we have unsigned versions of these. So let me make another comment. Unsigned versions. So we have uint, u long, and u short. So these are all unsigned, so meaning they go from pretty much 0 to double of what their number is. So a short will go from 0 to about 6,400 or 64,000, excuse me. So these are also declared the same way. So uint, my uint is equal to, something positive. It has to be a positive number, otherwise it will not accept it. U short, my short, my u short, and then something. So if I put a negative here, it will give me an error, as you may see. And then u long. My u long is equal to some number. We also have a signed version of our byte. So let me put this as signed version of byte. And this is called s byte. And it's literally just s byte, and then my s byte equal to negative 120. The range here is negative 128 to 127. So that's what we have. So again, I'll repeat this again. Don't go. I think I've repeated it. If I haven't, I'll say it. I'll say it once. So let's talk about overflowing. I don't think I've actually said it, so I'll do this down below. Overflowing is when you try to assign a type, a value to large for the container. So an example of this is, let's go with s byte equal to 129. Since an s byte goes from 128 to 127, or negative 128 to 127, 129 should be too large for it to hold, so we get an error here. If I drop this back to 127, it should work. Oh, excuse me. I have to say, we have to have a variable or a name for it. My byte. And then let's just do an underbar. So let me do that again to 129. We should get an error. It's too large for it to hold, so it cannot hold it. So I'm gonna comment this out as an example. So that is what overflowing is. Let's talk about scoping. So scoping is trying to, well, it's not really something, it's just, let's go with scope, is where you can access variables, or values pretty much. So values, because you can access constants as well. Where you can access values from, and so let me give you an example. So if we have an if statement, I'll be using if statements. So I have to tell you what they are. So they are statements that if a condition is met, a certain task will be done. So let me say int test int is equal to 10. If test int is equal to 10, so the difference, I'm going to tell you the difference between this equal sign and this equal sign. So this equal sign says that test int is equal to 10. This equal sign is checking if test int is equal to 10. So if I made this, let me finish the statement first. So let's say if it is equal to 10, let's have the console write I'm 10. So I'm 10. So this should run. It should say I'm 10. Now if I make this 0, it should not run into that. So it's pretty much checking for a condition. The condition is here, whether test int is equal to 10. So that's where we're at. So let me go back to scoping. So scoping is where you can access a value from. The if statement is within the main function. So if statement will have access to anything above it, pretty much. So anything declared above it, I'll have access to. So let me go back to my int1. I'll change it and then print it again. So I'll print first. Let me have the console write. So and then write line my int. It should print 1. It's capital I. So my int should print 1. And now if we edit my int, so my int is now equal to 25. And now let's write it again. My int. So now it should have 1 and then 25 at the very end, because we can edit it. We have access to it. So now let me declare an integer here. So int new int is equal to negative 1. All right, and we can run it. That's fine. So now let's try to access that integer from outside of here, outside the if statement. So let's say new int is now equal to 20. It'll give me an error because I'm trying to access it outside of the scope of new int. And the new int scope is only for the if statement. So I can access it only within here. Or if I were to declare something within here, so let's say if, let me do a Boolean. So let me declare Boolean, my new bool. So my new Boolean is equal to true. So if my new Boolean is equal to true, this can also be done this way. So let me show you another example. If my new bool, that checks if it's true. So let me check for true, and then this will be for false. So like exclamation mark. So my new bool. This would be for false. So this is just another way of doing exactly what I did here. So let's do that. So my new int. So let's change my new int. New int now equals to negative 10. And let's have console write it. New int. Let me comment that out. So as you may see, this is within the scope because everything that I'm using here is declared above it within this here, within these brackets. If I try to access it here, I'm outside of the brackets, and so I'm outside of the scope because it was declared here. Now I can access this integer if I declare it above. So let me move it up there. This won't give me an error anymore because it's declared within its own scope. So this would be in scope of this. So let me move that back over here. All right. So that is pretty much scoping and what you need to know about it. So let me put this an example of bad scope. All right, so that is pretty much what you guys need to know about, primitive types and scoping and overflowing. For you guys, I would like for you all to mess around with it, have some fun, use the if statements. They are, right now one of our first big things that we're learning. So play around with it, mess around with it, declare your own variables. Get familiar with the naming convention. You can do many things with it. But yeah, just go on back on Rex Tester, mess around with it, and just have some fun. So that concludes for today. That concludes today's videos. In the next tutorial, we'll learn about type conversion. Thanks for watching.
Hey everyone, thanks for watching this course. If you want to watch the rest of the course, the link is down below. Not only will you get the access to this course, but you'll get access to a lot of other courses in a huge bundle, and it's on sale today. So buy before the sale ends. Thanks for watching, and I'll see you in another video.